Hello everyone, it's PK again, and today we are going to do best time to buy and sell stock problem, which is a very popular interview problem, and it has also been asked in my Oracle interview. Not the same question but a variation of it. So we are going to do two variations of it and try and implement it in both the IDs, Leetcode as well as Geeks for Geeks. One is a Leetcode easier, the other one is Geeks for Geeks medium, and you can see that it is asked by multiple companies which kind of include almost all the popular companies. So let's start with this one. The question is very simple. You are just given an array with a set of prices. I'm going to change the array name to something small, and you're just given a set of prices, and each index represent that day, a specific day. So if it is 7, then it is the 0th index. This is the first index, and 0th index means 0th day. On that specific day, what would have been the prices of stocks? So on 0th day, the price of stocks would have been 7, and first day it would have been 1, and like that. So what you're supposed to do is find out a single day where you can buy all the stocks and another day where you can sell all the stocks, so that you can maximize the profit. So one thing you can see from this input is that if you buy all the stocks on 1 and sell all the stocks on 6, then that would be the most optimal way, because you can get the profit to 5, and you can't sell it on 7 because 7 is before 1. So one conclusion you can come from that is that if the array is in descending order, you can't possibly get it done. So I'll leave it to you guys. Like, if you want to stop and think about it, then go ahead. Else we're going to go for the approaches. The brute force approach would obviously be to iterate through the rest of the array for every element and figure out the least difference. So if it is 7, then you're going to iterate through the rest of the array and take the difference between, if it is greater, only if it is greater we are going to take the difference, else it is not possible. So for 7 there is no element which is greater than that. So we'll take for the next one, which is 1. And then you go to 1, and when you go to 1, you can check for the rest of the array, that is 5, 3, 6 and 4. If there's an element greater than 1, there of course is, and you go to 5 and take the difference between 5 and 1 and keep it into the profit, because initially profit is 0, and you update profit to 4 because 4 is greater than 0. And you go ahead and see another element 6, and you take the difference and you figure out that okay, now the profit is more, so you have to update profit, and that's how you get it done. But that is not very efficient because it costs you n square time, and you don't want that. So we can reduce that. There is another approach by using you can keep two arrays actually. One is prefix min and the suffix max. Prefix min is something which will keep track of like the smallest element from behind, and suffix min would be keeping track of the largest element from the other end. But that won't also be needed because we can just do that in a single variable. That would be the optimal approach. We can just do it in linear time and single variable. So how we can do that is just keep track of the smallest element that you have seen so far. So in this array, let's say you iterate from the beginning, and the smallest element that you have seen so far in the beginning would be 7. And you go for the next element. When you go for the next element, you initialize profit to 0 as well in the beginning. And when you go for the next element, you take the difference between the current element. If it is greater than the minimum that you have seen so far, only then you take the difference between that minimum and the current element and update the profit if it is greater than profit. So now it is 1, so you don't do anything over there, but you update the minimum that you have seen so far to 1. So now the minimum that you have seen so far would be 1, and the profit is still 0. Next you see 5. When you see 5, you take the difference between minimum you have seen so far and the current element. So that is 5 minus 1, so it will update to 4. Then when it's 3, nothing happens, and 6, it will change to 5, profit becomes 5, and minimum will all be 1 here, 1, 1, 1, 1, 1. And here profit won't change because the profit is still smaller. And that's how you get it done. Let's go ahead and implement it. If you are still doubtful of how it is being implemented, take a pause, think about it, and let's get it done then. Also, it is saying that the length of the array can be 1. So think what happens when length of the array is 1. It's pretty much nothing actually. When the length of array is 1, we can just buy, right? We can't sell the stock, so it is just loss, not profit. And if the length of the array is 1, we can just simply return 0. We cannot earn any profit there. So I'm going to take the size of the array in variable n, and a dot size, and I'm going to initialize profit 0. Also we can just, you know, we can just initialize profit to 0. Profit to 0. Right, and now we can put a for loop actually. And I equals profit 0. Okay, now we have to find out a minimum element, like initialize a minimum element that you have seen so far, right? So let's just give it along with it. Mn, let's give mn because min is a keyword, so mn, let's give it as the first element then. I'm gonna start from 1, I less than n, and I plus, and you actually check if a of I is actually greater than the minimum that you have seen so far. If a of I is greater than mn, then what you can do is take the difference and update the profit. So profit, I did type it right the first time, butterfingers, profit comma the difference, so a of I minus the min that you have seen so far, which would be mn. And if it is not the case, you can have to update min, so mn equals min of mn comma a of I. That should be it. Okay, there we go. Let's see if there are any errors. What happened? Are we updating profit? Okay, that is there, and we are updating min as well, right? What is going on here? If a of I greater than min, output is 0 actually. We are updating, oh my bad, it is max instead of min, just making it smaller than it used to be, supposed to be, and that should be it. Okay, let's run the sample test cases, and yeah, that should be it, and voila. Okay then, so let's go for the next one. So we have order n time complexity and order 1 space. I'm gonna try and sum it again to see if, yeah, okay, so we have like very less memory usage and very good time complexity, so that is good. Let's go for the next variation of this, and this is a slightly more difficult compared to the other one, but still the code is very small, it is very easy to implement, but you have to figure out something to get started with it. The question is very similar to the other one. The only difference is you can buy and sell multiple times instead of just one time. So if the test case was this, then what you would do is buy at 100 and sell at the next possible, I'll get to that, sell at 310, buy at 40, and sell at 395 to maximize your profit. So if it was just one, you would just buy at 40 and sell at 395, right? So here you can buy and sell at multiple instances to maximize the profit, and instead of returning the profit, you are supposed to return the day at which you're going to buy and sell at the day which you're going to sell. So here we are going to buy at 100, so 0, and sell at 310, which is 3, 4 at 40, and 695. So like in the previous case, if it is in descending order, we can't get it done. If the case is something like this, you can choose any of them. Like you can return 1 4, 2 4, or 3 4. All of them would be possible answers, and if the answer is right, they'll output 1, else they'll output 0. So if you want to take a pause and think about it, go ahead, else I'm gonna go for the approach. So I'll tell you the approach. What I think what you can do is, if you are not getting any hints, try writing some test cases down. You will find a pattern, and that pattern is that whenever you buy an item, it would be the local minima, and whenever you sell that item, it has to be the local maxima. So let's say in this array, when you're going to buy, you already know you're going to buy 100. The reason why you buy 100 is that it is because it is a local minima, because it is less than its neighbors actually. So 100 does not have any neighbor towards the left, and the right neighbor is greater, so this is a local minima. Similarly, these are not local maximas, because for 180 260 is greater, 260 310 is greater, but 310 it is greater than the neighbor, so L max. So you buy here, you sell here. Similarly, you buy because it's a minima and sell. If you write down a few test cases and analyze it, you will know that it will be true for all the cases. So that is how you get it done. So that's kind of pretty much it actually. You have to find out the local minima, and you will have to find out the next corresponding local maxima. And when you have both of them, you can just put it into an answer vector. So we are supposed to return test vector of vector. If you don't know what vector is, refer to some documentation. Geeks reference is good, you can check that out. Yeah, so that's pretty much it. So in this answer, we'll have to push back this and push back this and this as a pair. So let's go ahead and implement it. So what I'm going to do is find the first local minima, then go ahead and iterate and find out the corresponding local maxima to it, and then push it into the answer. So let's get it done then. Okay, right, so I'm going to initialize the answer vector first, where we are going to can type Okay, so we have an answer vector now, and I'm gonna make this small array, and I'm going to initialize a variable I, which should be the loop control variable, and I don't need a profit over here. I think that should be it. So while I less than n minus 1, I'm gonna put an outer loop, and I'm gonna use another while as well. So you might think that then this will cost you order n square complexity, but it is not going to, because we just have one loop control variable, which is I itself. So I less than n minus 1, and if I greater than or equal to if I plus 1. This is for local minima. So what we are trying to do is, if we have an element, current element is actually greater than the next current element is greater than the next element, then it would mean that the next element is smaller and the current element is not a local minimum. So we are going to increment I to find out the next local minimum, and when this condition evaluates false, then it would either be a local minima or the end of the array. So if I equal to n minus 1, then it is the end of the array. What you can do is simply break. And if it is not the case, then I can initialize two more variables, which is buy and sell. So buy would actually be the current index, and you have to increment that index because you are not going to sell at the same index, because you won't make any profit. So let's put another while loop to actually find out the maxima, which is next to that. So I less than n, and then if I minus 1 less than or equal to if I, then you can increment I. So what this is actually checking is, if the previous element is less than the next element, then you can increment and check if there are any greater elements towards the right hand side. and that would be the place where you are going to sell. And you can simply push the buy and sell, not I, actually it is I minus 1. So when the condition evaluates false, then it would mean that you will be selling at I minus 1, not I. So we can push it back into the answer, answer dot push back. Oops. And it will be buy and sell. That's pretty much it actually. Let's see. If you still didn't get it, just think about it. I'll provide the code in the description. You can look at that. First, think about it on your own. Then if you're stuck, then you can take a look at the code. But make sure you put your best of your efforts. It did take me some while, even though it is very simple. I did take a lot of time to actually think about it, and this is not right actually, because it took me like a lot of time to figure it out, and it is some kind of bug. When I submitted it again, it went back to something like this. So yeah, that is the sole problem. And people did say that the sound quality of my previous videos were not that good. I do understand that fact. I need a better mic actually. I have slightly improved it in this video. And some people were texting me in Instagram. I haven't been using Instagram for a while, so you can message me if you want to talk to me in person. It is Axis of Ignorance. Down in the description, you can catch me there. And if you like what I put over here, hit that thumbs up. And if you want more content like this, and if you want to keep notified whenever I post something like this, then go ahead and throw a short put on the subscribe button. Until we see again in another video, thank you for watching. Good night. Goodbye.